The requirements for locating a standby emergency generator, specifically for life safety emergency egress lighting in a supermarket, are detailed in both the National Electrical Code (NEC) Section 700 and the National Fire Protection Association Standard 110 Section 7.2. It's crucial to adhere to these regulations to ensure the safety and reliability of the emergency power system. Let's dissect the key aspects of each code to provide clarity on the appropriate generator placement. NEC Section 700 mandates that the emergency generator must be housed in a separate room or enclosure. This space must be exclusively dedicated to the emergency system. It emphasizes the need for a fire-rated room or enclosure, effectively isolating the generator and its associated equipment from the normal power electrical gear. This separation is achieved by a fire-rated barrier, which is designed to contain a fire within the enclosure, preventing its spread to other areas of the building. Now, let's consider NFPA 110, Section 7.2. Similar to the NEC, the standard requires that the emergency generator be located in a separate room or enclosure specifically dedicated to the emergency system. NFPA 110 further emphasizes that this room or enclosure must be fire-rated and separated from all other electrical equipment by a fire-rated barrier. This stipulation is more comprehensive than the NEC requirement, as it doesn't limit the separation to just the normal power electrical gear, but rather extends it to all other electrical equipment within the building. Now let's analyze the interpretation of these requirements. The stipulations of NEC Section 700 and NFPA 110 Section 7.2 are substantially the same. Both codes mandate that the emergency generator must be located in a separate, dedicated room or enclosure. This room or enclosure must be fire-rated and adequately separated from other electrical equipment by a fire-rated barrier. This implies a commitment to the physical isolation of the emergency power system from the normal power infrastructure to safeguard its functionality during emergencies. Now let's discuss the practical conclusion. Based on the requirements outlined in NEC Section 700 and NFPA 110 Section 7.2, a 45 kW generator cannot be located in the same room as the normal power electrical gear. The generator must be situated in a separate fire-rated room or enclosure that is exclusively dedicated to the emergency system. This underscores the importance of adhering to safety regulations to ensure the reliable operation of the emergency power system, especially in critical situations such as power outages. Now, let's dive a bit deeper into the specific aspects of fire rating. The fire rating of the room or enclosure is determined by the applicable building codes and standards, and is typically expressed in terms of the amount of time the enclosure can withstand exposure to a standardized fire test. Common fire ratings include 1-hour, 2-hour, and 3-hour ratings, with higher ratings indicating greater fire resistance. The selection of the appropriate fire rating will depend on the specific characteristics of the building, the occupancy type, and the potential fire hazards present. It's crucial to consult with a qualified fire protection engineer or building code official to determine the appropriate fire rating for the generator enclosure. Furthermore, the fire-rated barrier that separates the generator enclosure from other areas of the building must also meet the required fire rating. This barrier can be constructed of various materials, such as concrete, masonry, or fire-rated gypsum board. The barrier must be continuous and free of any openings or penetrations that could compromise its fire resistance. Any penetrations for electrical conduits, pipes, or other services must be properly sealed with fire-stopping materials to maintain the integrity of the barrier. The automatic transfer switch, or ATS, is a critical component of the emergency power system, as it automatically transfers the building's electrical load from the normal power source to the emergency generator in the event of a power outage. The ATS should be located in close proximity to the generator to minimize the length of the emergency power conductors. However, it's important to consider the potential for fire hazards when locating the ATS. If the ATS is located within the same room as the generator, the entire room must meet the fire rating requirements. Alternatively, the ATS can be located in a separate fire-rated enclosure adjacent to the generator room. This arrangement can simplify the fire protection requirements, as only the ATS enclosure needs to be fire rated. Now let's consider the ventilation requirements for the generator enclosure. Emergency generators produce heat and exhaust gases during operation, so adequate ventilation is essential to prevent overheating and the accumulation of hazardous fumes. The ventilation system should be designed to provide sufficient airflow to remove the heat and exhaust gases from the enclosure. The exhaust gases must be discharged to the outside of the building in a safe and compliant manner. The ventilation system should also be equipped with a means of preventing the entry of rain, snow, and other debris into the enclosure. This can be accomplished by using louvers, dampers, or other protective devices. The generator enclosure should also be equipped with a fire suppression system to extinguish any fires that may occur within the enclosure. The fire suppression system can be either a wet chemical system or a dry chemical system. The selection of the appropriate fire suppression system will depend on the specific characteristics of the generator and the enclosure. The fire suppression system should be designed to automatically activate in the event of a fire. It's also important to ensure that the fire suppression system is properly maintained and inspected on a regular basis to ensure its proper operation. Furthermore, the generator enclosure should be equipped with appropriate safety signage to warn personnel of potential hazards. The signage should include warnings about the presence of high-voltage electricity, flammable materials, and hazardous exhaust gases. The signage should be clearly visible and legible, and should be located in prominent locations throughout the enclosure. In addition to the code requirements, it's also important to consider the practical aspects of generator placement. The generator should be located in an area that is easily accessible for maintenance and repair. The area should be well lit and free of obstructions. The generator should also be protected from the elements such as rain, snow, and extreme temperatures. Furthermore, the generator should be located in an area that is not subject to flooding or other water damage. Now, let's discuss the importance of regular maintenance and testing. Emergency generators should be regularly maintained and tested to ensure their proper operation. The maintenance schedule should be based on the manufacturer's recommendations and the specific operating conditions of the generator. The maintenance should include regular inspections, cleaning, and lubrication. The testing should include load testing to verify that the generator can provide the required power output. The testing should also include automatic transfer testing to verify that the ATS can properly transfer the building's electrical load to the generator in the event of a power outage. It's also important to keep accurate records of all maintenance and testing activities. These records should be kept on file and should be available for inspection by code officials. Compliance with the code requirements for emergency generator placement is essential to ensure the safety and reliability of the emergency power system. By following these guidelines, you can help protect the building occupants and prevent property damage in the event of a power outage. Now, let's further elaborate on the specific requirements and considerations related to the installation and operation of emergency generators, focusing on the relevant sections of NEC 700 and NFPA 110. NEC 700 addresses the emergency systems in detail, covering aspects such as wiring methods, permissible transfer equipment, and circuit loading. Section 700.12 specifically focuses on the sources of power for emergency systems, including generators. It stipulates that the emergency power source must be capable of supplying power to the emergency load for a minimum duration, typically 90 minutes to several hours, depending on the application. Furthermore, it mandates that the generator must be equipped with automatic starting and transfer capabilities to ensure a seamless transition to emergency power in the event of a normal power failure. NFPA 110, titled Standard for Emergency and Standby Power Systems, provides a comprehensive set of requirements for the performance, maintenance, and testing of emergency power systems. Chapter 5 of NFPA 110 addresses the installation and design of emergency power systems, including generators. It specifies the requirements for generator sizing, fuel supply, ventilation, and exhaust systems. It also mandates that the generator be equipped with a remote annunciation system to provide alerts in the event of a generator malfunction or failure. Now let's delve into the practical implications of these code requirements for the supermarket application mentioned earlier. The requirement for a separate, fire-rated room or enclosure for the emergency generator means that the generator cannot be located in the same room as the normal power distribution equipment. This is because the potential for a fire in the normal power distribution equipment could compromise the operation of the emergency generator, and vice versa. The fire-rated enclosure is designed to protect the generator from fire damage and to contain any fire that may occur within the enclosure. The fire rating of the enclosure is typically based on the building code requirements for the occupancy type and the fire hazard classification of the area. This separation requirement also extends to other electrical equipment, such as lighting panels, control panels, and communication equipment. This is to ensure that the emergency generator is not affected by any electrical faults or disturbances in the normal power system. The fire-rated barrier must be continuous and sealed to prevent the passage of smoke and fire. Any penetrations for conduits, pipes, or cables must be properly fire-stopped to maintain the integrity of the barrier. The generator room must also be adequately ventilated to remove heat and exhaust gases. The ventilation system must be designed to provide sufficient airflow to prevent overheating and to ensure that the exhaust gases are safely discharged to the outside of the building. The exhaust system must be equipped with a spark arrestor to prevent the emission of sparks or embers that could ignite combustible materials. The generator must be equipped with a fuel supply that is adequate to operate the generator for the required duration. The fuel supply must be stored in a separate, fire-rated tank that is located in a safe and accessible location. The fuel tank must be equipped with a level gauge and an overfill prevention device. The generator must also be equipped with a battery system to provide power for starting the generator. The battery system must be properly maintained and tested to ensure its reliability. The automatic transfer switch must be located in a readily accessible location and must be protected from damage. The ATS must be capable of automatically transferring the building's electrical load from the normal power source to the emergency generator in the event of a power outage. The ATS must also be capable of automatically transferring the load back to the normal power source when power is restored. The emergency lighting system must be designed to provide adequate illumination for safe egress from the building in the event of a power outage. The emergency lighting system must be powered by the emergency generator and must be automatically activated when the normal power fails. The emergency lighting system must be tested regularly to ensure its proper operation. Finally, it's important to emphasize the need for qualified personnel to install, maintain, and test the emergency power system. The work must be performed by licensed electricians and certified generator technicians who are familiar with the applicable codes and standards. Regular inspections and maintenance are essential to ensure the reliable operation of the emergency power system. In summary, complying with NEC 700 and NFPA 110 is crucial for ensuring the safety and reliability of emergency generator systems. Careful consideration must be given to the location, fire protection, ventilation, fuel supply, and maintenance of the generator to meet the code requirements and to provide a safe and effective emergency power system. Now let's expand on the discussion of generator sizing, a critical aspect of emergency power system design. The generator must be sized appropriately to handle the connected emergency load. This requires a thorough assessment of the loads that will be powered by the generator during a power outage. These loads typically include emergency lighting, exit signs, fire alarm systems, and other critical life safety equipment. The generator must be capable of providing sufficient power to operate all of these loads simultaneously with an adequate margin for future expansion. The generator sizing calculation should take into account the starting inrush current of motors and other inductive loads. These loads can draw significantly higher current during startup than their normal running current. The generator must be sized to handle these inrush currents without causing voltage dips or frequency fluctuations that could affect the operation of other equipment. The generator's power rating is typically expressed in kilowatts or kilowatts. The kilowatt rating represents the continuous power output of the generator. The kilowatt rating represents the short-term power output of the generator, typically for a duration of 30 minutes or less. The kilowatt rating is typically higher than the kilowatt rating. The generator size and calculation should be based on the kilowatt rating, as this represents the continuous power output of the generator. It's also important to consider the dating factors that may apply to the generator. Dating factors are applied to account for factors such as altitude, ambient temperature, and humidity. These factors can reduce the generator's power output. The generator manufacturer can provide information on the appropriate dating factors for the specific generator model. Now let's move on to the discussion of fuel supply requirements. The fuel supply for the emergency generator must be adequate to operate the generator for the required duration. The duration is typically specified in the applicable codes and standards. For example, NFPA 110 typically requires a minimum fuel supply of 2 hours for Level 1 emergency power systems and 8 hours for Level 2 emergency power systems. The fuel supply can be provided by a diesel fuel tank, a natural gas pipeline, or a propane tank. The choice of fuel depends on factors such as availability, cost, and environmental considerations. Diesel fuel is the most common fuel for emergency generators. Diesel fuel is readily available, relatively inexpensive, and has a high energy density. Natural gas is a cleaner burning fuel than diesel fuel. However, natural gas may not be available in all locations. Propane is another clean burning fuel that can be used for emergency generators. However, propane is typically more expensive than diesel fuel or natural gas. The fuel tank must be sized appropriately to hold the required amount of fuel. The fuel tank must also be located in a safe and accessible location. The fuel tank must be protected from damage and must be equipped with a level gauge and an overfill prevention device. The fuel supply system must also include a fuel filter to remove contaminants from the fuel. The fuel filter must be replaced regularly to ensure that the fuel is clean and free of contaminants. The fuel supply system must also be equipped with a fuel shutter valve to stop the flow of fuel to the generator in the event of an emergency. The fuel shutter valve must be located in a readily accessible location. Now let's discuss the ventilation and exhaust system requirements in more detail. The emergency generator must be adequately ventilated to remove heat and exhaust gases. The ventilation system must be designed to provide sufficient airflow to prevent overheating and to ensure that the exhaust gases are safely discharged to the outside of the building. The ventilation system must comply with the applicable codes and standards. The ventilation system must be designed to prevent the entry of rain, snow, and other debris into the generator room. The ventilation system must also be equipped with a means of preventing the backflow of exhaust gases into the building. The exhaust system must be designed to discharge the exhaust gases to a safe location away from building occupants and other sensitive areas. The exhaust system must be equipped with a spark arrestor to prevent the emission of sparks or embers that could ignite combustible materials. The exhaust system must also be designed to minimize noise pollution. The exhaust system must be constructed of materials that are resistant to corrosion and high temperatures. The exhaust system must be properly supported and anchored to prevent vibration and movement. Now let's elaborate on the automatic transfer switch, or ATS requirements. The ATS is a critical component of the emergency power system. The ATS automatically transfers the building's electrical load from the normal power source to the emergency generator in the event of a power outage. The ATS must be capable of automatically transferring the load in a timely manner, typically within 10 seconds. The ATS must also be capable of automatically transferring the load back to the normal power source when power is restored. The ATS must be located in a readily accessible location and must be protected from damage. The ATS must be properly sized to handle the connected load. The ATS must be listed and labeled by a recognized testing laboratory. The ATS must be installed in accordance with the manufacturer's instructions and the applicable codes and standards. The ATS must be regularly inspected and maintained to ensure its proper operation. The ATS must be tested periodically to verify its ability to transfer the load automatically. Now let's address the requirements for remote annunciation and monitoring. NFPA 110 requires that emergency power systems be equipped with a remote annunciation system. The remote annunciation system provides alerts in the event of a generator malfunction or failure. The remote annunciation system must be located in a continuously staffed location, such as a security office or a fire command center. The remote annunciation system must provide visual and audible alarms to alert personnel of the generator malfunction or failure. The remote annunciation system must monitor various parameters such as generator voltage, frequency, and current. The remote annunciation system must also monitor the status of the ATS and the fuel supply. The remote annunciation system must be capable of transmitting alarms to a remote monitoring center. In addition to remote annunciation, it's also important to consider remote monitoring of the emergency power system. Remote monitoring allows personnel to monitor the performance of the generator remotely from a central location. Remote monitoring can provide valuable insights into the operation of the generator and can help to identify potential problems before they lead to a failure. Remote monitoring can also be used to track fuel consumption and to optimize generator performance. Now, let's emphasize the importance of proper grounding and bonding. Proper grounding and bonding are essential for the safe and reliable operation of the emergency power system. Grounding provides a path for fault current to flow back to the source, which helps to protect equipment and personnel from electrical shock. Bonding connects all metallic parts of the electrical system together to create a low impedance path for fault current. The grounding and bonding system must comply with the applicable codes and standards, such as NEC 250. The grounding electrode system must be properly installed and maintained. The grounding electrode system must be connected to the generator frame, the ATS enclosure, and the electrical panels. The bonding jumpers must be properly sized and installed. The grounding and bonding system must be regularly inspected and tested to ensure its effectiveness. Now, let's discuss the importance of coordination with the local utility company. It's important to coordinate with the local utility company when installing an emergency generator. The utility company may have specific requirements for the connection of the generator to the utility grid. The utility company may also require that the generator be equipped with a paralleling switch to allow the generator to operate in parallel with the utility grid. Paralleling allows the generator to supply power to the grid, which can help to improve the reliability of the grid. Paralleling requires careful coordination with the utility company to ensure that the generator operates safely and does not interfere with the operation of the grid. Now let's conclude by reiterating the importance of qualified personnel. The installation, maintenance, and testing of emergency power systems must be performed by qualified personnel. Qualified personnel are licensed electricians and certified generator technicians who are familiar with the applicable codes and standards. Qualified personnel have the knowledge and skills to install, maintain, and test emergency power systems safely and effectively. Qualified personnel can help to ensure that the emergency power system complies with the applicable codes and standards and that it operates reliably in the event of a power outage. Regular training and continuing education are essential to ensure that personnel remain qualified. By following these guidelines, you can help to ensure the safety and reliability of your emergency power system.